In this video, we are going to look into hydroboration oxidation reaction. This reaction provides another way to convert an alkene into an alcohol, but its regiochemistry and stereochemistry are different from acid-catalyzed hydration. We will compare these two methods, review the concerted hydroboration step, discuss syn addition, and then apply these ideas to product and region prediction problems. Hydroboration oxidation occurs in two stages. First, the alkene reacts with the borane, BH3, in THF to form an organoborane. In this example shown, boron becomes attached to the less substituted carbon, while the hydrogen is delivered to the more substituted alkene carbon. In the oxidation step, hydrogen peroxide under basic conditions replaces the carbon-boron bond with the carbon-oxygen bond, giving an alcohol. The overall result is anti-Markovnikov of hydration. The OH group appears on the less substituted carbon of the original double bond. For 2-methyl-2-pentene, the product shown is 2-methyl-3-pentanol. The comparison highlights the opposite regiochemistry of the two hydration methods. When propene undergoes acid-catalyzed addition of water, the reaction follows Markovnikov orientation and produces 2-propanol with an OH on the more substituted carbon. When the same alkene undergoes hydroboration oxidation, the OH is going to appear on the less substituted carbon, and it is going to produce 1-propanol instead. So, when you are choosing the reagents, first inspect where the OH group must appear. A Markovnikov alcohol suggests acid-catalyzed hydration or another Markovnikov method, while an anti-Markovnikov alcohol strongly suggests hydroboration oxidation. A key difference from acid-catalyzed hydration is that hydroboration is concerted. One formation to the hydrogen and boron occurs in the same overall step, so a free carbocation is never formed. Because there is no carbocation intermediate, there is no opportunity for a hydride shift or alkyl shift. The boron portion of the reagent is electrophilic and becomes bonded to the less substituted alkene carbon, the carbon bearing the hydrogens. Oxidation then replaces this carbon-boron bond with the carbon-oxygen bond without changing the regiochemical placement. This explains both the anti-Markovnikov product and the absence of carbocation rearrangements. Hydroboration is also stereospecific in the sense that hydrogen and boron is going to be delivered to the same face of the double bond. During oxidation, the boron-containing group is replaced by OH, so the overall addition of hydrogen group and the OH group is syn. The example on the slide showed that the alkene can be approached from either side. If the substrate is achiral and both faces are equivalent, then attack from both faces can happen, and it is going to produce a pair of enantiomers. In each individual product, however, the newly added hydrogen and OH are on the same phase. So remember the two defining features together, anti-Markovnikov regiochemistry and syn stereochemistry. Let's try to do some practice questions. So before I explain what is happening in here, pause the video and try to predict the product. So for this alkene, begin by identifying the less substituted carbon of the double bond. So this is your double bond. Try and identify which double bond carbon is less substituted. On this side, on the left side, this carbon is having two substituents. And if you look into the other carbon, other double bond carbon, it is only having one longer carbon chain. So among the two alkene carbons which are sp2 hybridized, carbon number A is most substituted, carbon number B is less substituted. So when we try to do the hydroboration replaces or places boron on the less substituted alkene carbon and hydrogen on the more substituted carbon. So when we try to draw the predict, You need to draw the rest of the molecule as it is. You need to open up the 5 bond, and then BH2 group will be placed on the less substituted carbon, and hydrogen will be placed on the more substituted carbon. And then when we do the oxidation step, this BH2 group will be replaced by an OH group. So finally, we are going to end up having 2-methylhexane 3R. Because a new stereocenter is formed at the alcohol-bearing carbon, we need to think of producing the enantiomeric pair. This is the next question. What reagents are needed to accomplish the following reaction? Pause the video and take a moment to think what is happening in here. Look carefully at the regiochemistry of the target alcohol. The ethyl substituent is placed, it remains on the more substituted alkene carbon, while the OH group in the product is at the less substituted carbon of the original double bond. So this is anti-Markovnikov of hydration. Therefore, the reagent sequence that matches the product drawn is hydroboration oxidation. First, you have to add borane BH3 in THF, followed by hydrogen peroxide and hydroxide. This slide summarizes 3 common methods for converting an alkene into an alcohol and compares their regiochemistry. The first method is acid-catalyzed hydration. In this reaction, an alkene reacts with water in the presence of an acid, such as dilute sulfuric acid or phosphoric acid. The reaction follows Markovnikov rule, meaning the hydroxyl group or the OH is added to the more substituted carbon of the double bond. For example, hydration of propene produces 2-propanol. Because of this reaction proceeds through a carbocation intermediate, carbocation rearrangements are possible. The second method is oxymercuration demercuration. This reaction also gives Markovnikov alcohol, so the OH group is added to the more substituted carbon. The reaction is carried out in 2 steps. First, using the mercuric acetate and water, followed by sodium borohydride. Propane again produces 2-propanol. An important advantage of this method is that carbocation rearrangements do not occur. Third method is hydroboration oxidation. This reaction has the opposite regiochemistry. It follows anti-Markovnikov rule, meaning the OH is added to the less substituted carbon of the double bond. Therefore, hydroboration oxidation of propene produces 1-propanol. This reaction also occurs without rearrangements. So remember, acid-catalyzed hydration and oxymercuration demercuration give Markovnikov alcohols, while hydroboration oxidation gives anti-Markovnikov alcohol. We have not discussed oxymercuration demercuration so far, and we will discuss it in another video.